So, let's go over some homework questions. I have the first three conceptual questions bunched together again, so let's just take them all at once. Number 4 is the one where you squirt a hose considerably greater distance by placing your thumb over the end of the garden hose and then releasing it. This would be a version. Can we do all of these with Bernoulli's equation? P1 plus 1/2 rho V1 squared plus rho G Y1 equals P2 plus 1/2 rho V2 squared plus rho G Y2. How far off the board did I go? Not too bad. All right, so in this version of Bernoulli's equation, what we're talking about is a case where we're going to change the pressure. The pressure on one side, inside the hose, is going to be bigger than the pressure outside the hose because we put our thumb over it and the water kept piling up on top of itself to the point that when we release it, it kind of explodes out of there. More or less like shaking up a soda bottle and then taking the cap off and the water comes out. So what? Explain why this works. It works because we're building up pressure. Number 14, it is dangerous to stand close to railroad tracks when a rapidly moving commuter train passes. Explain why. Atmospheric would push you toward the train. That's the whole deal. Yeah. Y1 and Y2 are the same. So here we have a case where high pressure corresponds to low velocity and low pressure corresponds to high velocity. So the high velocity train that's moving by is creating a region of relatively low pressure. Atmospheric pressure behind you would tend to push you into that region of low pressure. So there's that one. And then number 20, we have the old rubber boot. And our boot has a leak here and a leak here, and it's filled with water that's filling the whole thing. So the velocity here is relatively low. The velocity here and here is relatively high. In terms of velocity, remember from physics 1, we would figure out how high the football was kicked, and we'd have to do the most important thing ever. So here, y equals v1 sine theta squared over 2g. Here the height doesn't change at all. It just has a velocity as it comes out. The velocity for both 1 and 2 is going to be the square root of 2gh. So the same velocity, same exit velocity, but the height difference is going to be by virtue of the fact that this velocity is coming out at some angle. And so we want the y-axis component of that velocity to then figure out its height. Either case, the gravitational potential energy of these water molecules that is revealing itself in kinetic energy, 1/2 mv squared, of these water molecules. The actual masses come out in the wash, mgh, 1/2 mv squared. So the masses don't matter so much, but the velocities do change. Hope that helps.